Pearl and I spent a week in Shenzhen visiting all of the people and places that make the various parts that go into a Metroboard. As something that started as a two-person art project, your interest and the thousands of people who have backed this project expanded the scale of creation far beyond what I had ever anticipated and beyond what either of us had experience in. So we spent the last year scaling from one Metroboard to 8,000. Making a Metroboard looks a lot different now than it did a year ago, so we thought you might be interested in seeing what that looks like. We're starting from the inside out.
Hello. Nice to meet you.
This is the SMT factory, where our circuit boards are assembled. Solder paste is applied with a large steel stencil, and the board is put on an automated conveyor belt to be ferried through some pick-and-place machines. These machines do just that. They pick up chips, and they place them on the board. They work stupid fast, placing about 3 parts per second. The factory actually slowed down the machine so that we could see it work in the video. The boards then go through a reflow oven with different temperature zones to fix the parts on for good. A manual inspection makes sure there's no visible issues with the boards, and then a camera system does the same. And that whole process only gets us through the circuit board. It's an experience I can't fully describe to see documents we made an ocean away plugged into a machine and spitting out real, functional circuit boards. A quick cup of tea and some chats, and we are back on the road. Next stop, foam. The foam shop is a 1,000-square-foot operation on the 5th floor of a walk-up in suburban Dongguan. They do a ton of different work, and frankly, we only use their simplest capability, cutting foam. It's for what we call our light shield, something we added to Metroboard when our first prototypes had so much light leakage that it turned every train into 2. And so the light shield was born. These shields start as huge rolls of EVA foam, cut to size on a bandsaw before getting zapped in a CNC laser cutter, and any loose bits are blown away with a pressurized air gun. With that sorted, it's on to one of the biggest visual pieces of the board, the aluminum. The visit starts with a cup or 3 of good tea, and then we step inside a factory that feels like a sci-fi movie set. This is probably closer to what I'd imagined a mass production factory to be before we visited. Lots of machine whirring and hydraulic hisses. It's where the front panel, rear panel, and stands for each Metroboard are made, cut to shape in a CNC machine. The faster the laser moves, the quicker these get made, and the lower the cost. But in an earlier pilot run, we ran this process at high speed, and the holes were visibly jagged, so we slowed the cuts down by 60% to solve the problem. Fresh out of the CNC machine, the edges are like tiny knives, so each piece is ferried over to a smaller CNC mill for some much-needed chamfering, which also happens to be a fantastic word, chamfer. A jig is used to keep them in place and properly positioned. Once this is done, our sheet metal factory has finished its job. The panels get sent to another facility to be sanded and bent to shape. We didn't make it there this trip, but here's some footage they sent us of the process. And with that, we are on to the next part. Resin. We had to make sure we were looking our best, so we got on our matching outfits before heading in to see our light diffusing resin being applied. This machine uses overhead cameras to identify all of the holes in the sheet metal before using its little resin dispensing arm to deposit a drop in each LED hole. The sheet metal has a transparent adhesive taped to the front so that the resin doesn't leak through while it's still liquid. After a layer of resin has been installed in each hole, a batch of finished panels are taken to a vacuum chamber and placed inside to remove air bubbles. After this process, the panels go back into the dispensing machine for another round of resin application. After that, they get 24 hours of rest while the resin cures and becomes hard. Once cured, on to the next step. There are 2 ways that text is printed on Metroboard. The first is silk screen printing, which we didn't get to see on this trip, but we got some footage from the factory. This is how the maps, station names, and rear panel button text are applied. On the rear panel, we also have some required regulatory information that we need to print. This we engrave with a low-intensity laser. It is very quick and also very beautiful. We don't use much plastic for Metroboard. But there are a few areas where it made sense, namely the USB connector area, or more affectionately the axolotl on account of his cute and rather salamandery body, as well as the keycaps, the picture hook cavity, and the screw spacer that we include as part of the mounting kit. If you're like me and never gave a moment's thought to how plastic gets to be all those funky shapes, allow me to introduce you to tooling. It's essentially a giant steel block precisely carved out to be a mold for the plastic part. Plastic can get melted down to liquid and injected into this cavity. When the plastic cools and the negative is opened, you've got your part. These plastic parts are inspected against the drawings that we provided to make sure that everything's up to scratch. The wood factory is small but mighty. They have been operating for over a decade, making hundreds of different wood products for both small businesses and large multinational conglomerates. Every part of the Metroboard frame is handmade here. Starting with planks of walnut, cut down with a basic table saw to the proper thickness and then to the right lengths. The strips go through a large belt sander until smooth to the touch, before heading to the router to create the lip for the frame. The edges are cut to 45 degrees so that they can be joined for the final frame. Finally, pilot holes are drilled so that the aluminum front panel can be easily mounted. Now the individual pieces are ready to come together for the final frame. The frame is glued together, and a 2-blade saw is used to notch each of the frame corners. These notches are for the miter keys. Miter keys are these little triangles used to bridge the edges and ensure a strong connection. Once the glue has settled, the entire frame is manually sanded on all outer faces to remove any nicks or roughness. It is real craftsmanship at work. We were super picky about the quality of this part, and these frames are nothing short of gorgeous. And they also had our favorite welcoming committee out front. From the shop, we were on to our last step before assembly: regulatory. Here is Metroboard undergoing conducted emissions testing. I'll let Kirill explain it.
This thing right here, this is called the Resin, and it connects to there, to the brick that powers the product. The point of that device is to measure any noise that the product charger system kicks back onto the AC line. So if the brick is noisy, or the product is noisy, or the cable is noisy, or the product cable charger combination is noisy, it'll kick back noise through the Resin, and they'll measure the noise that it kicks back onto the AC mains.
Essentially, we're testing Metroboard to make sure it's not noisy or interfering with any of your other household electronic appliances. We did fail this test, but pinpointed the issue to the charger brick that we were using, not Metroboard. So we called up the factory that makes the brick and had them retool its innards, and we passed with flying colors. Metroboard goes through about a dozen different tests to get our FCC and CE certificates, most as visually sleepy as this one, so we'll spare you those, but here are the certificates of the testing company that we've used so that you know we're doing things by the book. We got a lovely tour of their very extensive facilities before heading off to the final step of the Metroboard journey: assembly. All of the individual parts we just watched get made are shipped here. At an assembly workbench, Metroboard is advanced through each step of the assembly, complete with detailed instructions and parts. Each step will have a specialized hand for assembly. Moving along the bench, Metroboard gets closer and closer to complete. Once fully assembled, it's handed off to quality for final checks. These are both cosmetic, to make sure there's no scuffs and scratches, but also functional, to make sure firmware and software are functioning properly. And then, boom. There's your Metroboard. From start to finish, dozens of people, thousands of parts, one Metroboard. And then we do it again, and again and again and again until it's thousands. And at this point, the we isn't just Kirill and I, the way it was when we started this whole thing. The we now spans factories, states, continents. It includes craftsmanship beyond what we ever could have accomplished ourselves. When we first started the logistics portions of this project, the scaling bits, I had this sinking feeling that something that had started as art was becoming just product. The part of making that is done with hands suddenly wasn't in my hands anymore, so it felt distant and abstract and big. And it is some of that now. Part of the growth was introducing distance and size and abstractness, increasing complexity, making the project something for more people and by more people. It's a different story than the one that we started out with, but it is ongoing, and so we're telling it. It also owes a massive thank you. None of what we just showed you existed a year ago, and it wouldn't exist today without you. And yes, your support, your patience, your kind words and understanding have very much been a part of this for us. We're grateful for your time and attention, and we can't wait to bring your Metroboard home to you.